at this time. So let me go ahead and get my PowerPoint pulled up and let's take a look at that together this morning. And Jill, what we'll do this morning, like we normally do, if you'll kind of be the monitor and look at the chat box and all that in case we have a specific question.
You bet, we're all good.
And can everyone see my screen okay?
Yes.
Okay, good, excellent. Well, again, this morning, team, we're going to be talking about the HMH7 SEER heat pump, and this will be an overview of the product and some of the key things we're going to be talking about specifically. The relays and how do you apply the relays. And this morning, we're going to literally be going wire for wire on the hookup. But before we get started, I'd ask everyone to please remember that the unit service fittings are 5/16 flare. And so an adapter will be required to go from your 5/16 hose fitting to your 1/4-inch service hoses. So be sure and have some of those fittings. There's several companies that make these, Robinair, Yellow Jacket, just to name a couple. We've got a bit of a echo in the background. So if everyone would mind, if you wouldn't mind, go ahead and mute your mic. And then if you do have some good questions, go ahead and unmute the mic. We'll ask those good questions and then we'll address those questions after you unmute your mic. So anyway, thank you for doing that. So anyway, back to the service thing. Just remember, it's a 5/16 flare fitting on the product, and you'll have to go down to the 1/4-inch on your service hose. Another thing I get asked quite a bit when we start talking about the product, team, is the fact that, what is their minimum and maximum heating and cool temperatures outside? So as you can see, our minimum temperature for cooling is 35 degrees. And in the heating mode of operation, it's -5. Now, it should be noted that these products will actually heat at approximately 50% of their capacity, all the way down to 0 degree Fahrenheit outside. So that's pretty remarkable for a heat pump. And so to put that in perspective, if I have a 3-ton heat pump, I'm still making somewhere around 18,000 BTUs of heat at 0 degrees Fahrenheit outside. Our maximum temperature is 122 degrees outside for cooling and 75 degree for heating as far as a max min temperatures. Any questions or comments on that? This is found by the way, right in the install guide. So it's a lot of good information in that install guide. I certainly encourage everybody to read that. But any questions or comments so far? Thumbs up, everybody good? All right. So at this time, we're going to be discussing low voltage wiring and setup on the heat pump. We're going to start out with an AE air handler, which is going to feature just a standard ECM motor. Now, remember, guys, when I talk about the ECM motor or the standard ECM motor, I'm talking about the X13 style of motor. You've seen those before, where you have a high efficiency motor, but you've actually got speed taps on there, 1, 2, 3, 4, 5 speed taps. So that's the motor we're going to be featuring to start out with this morning. We're going to go ahead and talk about the low voltage wiring with an AE air handler and some simplified block wiring diagrams. What we're going to be doing this morning is we're going to be literally taking it from the thermostat to the indoor unit to the outdoor unit. Now, please remember, the air handler does not have terminals, but is equipped with pigtail connections. Now, on the block diagrams, I actually show a block where we're actually hooking up those low voltage terminals. But just please remember, on the air handler, they don't have physical terminals, but they are pigtail connections. And then on the furnaces, they're an actual hard screw terminal. But you'll notice that on the block diagrams, just to make it easy to look at, you'll notice that I'll have just a block. It'll say W1, and so on, and that'll be our connection. But just please remember, they're pigtail connections on the AE air handler. We're also going to talk about the wiring of the accessory single pole double throw relay in the indoor unit and how it's going to be used for airflow reduction. Now, this is going to be important because as we set up this heat pump with an indoor product, we want to be able to reduce our airflow to 60% airflow when we have that low airflow command. And then high airflow, of course, will be 100% airflow based on 400 CFM per ton of cooling capacity. So let's go ahead and talk through that for a minute or two. So if I have a 2-ton unit outside, I want to make sure and set up my airflow for 800 CFM total or in other words, 400 CFM per ton. If I've got a 3-ton unit setting outside, I'm going to want to make sure that my ductwork and my airflow settings are set up for 1200 CFM and so on. On a 4-ton unit, it would be 1600 CFM and so on. So we want to make sure that we set our airflow up properly on these things. It's very, very important that we have proper airflow. And we also want to make sure that our airflow reduction, when we reduce the airflow, that reduced airflow needs to be about 60% of our full airflow. So again, we set it up for 400 CFM per ton on the high-speed cooling airflow, and then 60% of that for our reduced airflow command. And we're going to do all that by utilizing a single pole double throw relay in the indoor unit. And we're going to recommend kit number HMH7AK001 for convenience and supplied parts. So basically what this is, it's going to be a little relay mounted on a board, and it's going to have some pre-made harnessing or pre-made wires that you can just hook up. And then it's also going to have a bi-flow filter dryer in that kit. And so this unit does not come with a factory installed filter dryer, brazed into the outdoor unit. It's something that the contractor, you guys will have to add when you install these things. And again, we're going to recommend that kit, that 001 kit, for convenience and all the supplied parts. Now, the burning question comes, well, what if I can't get that kit, or what if, my local wind supply company doesn't have them, or whatever the case may be? What do I do? Well, you can still make that kit up yourself, and that's kind of a separate little session. But we do have a white paper that I had generated that goes over the parts necessary to make that kit up if you need to make that kit up. But we recommend that kit, that 001 kit, because of all the supply parts. Now, it should be noted that there's another kit, a 002 relay kit, and that's going to be for variable speed products. So the 002 kit, HMH7AK002 kit, is going to be for variable speed products. However, it should be noted that 002 kit, the only difference between the 001 and the 002 kit is the 002 kit has 2 relays instead of just 1 relay. That's how you know the difference between them. The 1 means it's just 1 relay on the little board. The 2 means there's 2 relays on the board. And so you can use that 002 kit if you have to. However, one of the relays, specifically the RV relay, will not be needed for this application. So kind of summarizing this whole thing, you have to have the 002 kit for anything variable speed. However, the 002 kit, you can kind of consider it a universal kit. It'll work on anything, but you have to have it for variable speed. And so, but you can use it in place of a 001 if you have to. Any questions or comments on that before we continue? You're going to see pretty quickly how it's all going to tie in with the block diagrams, but I just wanted to make sure that we talked about those kits a little bit because it's important that we have access to those. Any questions on that? Okay. In addition, if you're going to have these set up, you're going to use just a regular heat pump thermostat, but you're going to have to make sure that whatever heat pump thermostat you use, and I want to stress these are just 24-volt thermostats. These are non-communicating standard heat pump thermostats. So whatever your favorite thermostat is, an Aprilaire or a Robert Shaw or a Honeywell, your favorite heat pump thermostat is going to be compatible with these products. Now, we want to make sure that the heat pump thermostat that you select has a BO selection for reversing valve operation, because we're going to learn here shortly that the HMH7 heat pump utilizes the B terminal. Let me say it again, the B terminal for heating, which is exactly opposite of our other Champion products. So our other heat pump products, we use the O terminal for cooling. On the HMH7, we use the B terminal for heating. It's not bad, it's just different. And we just need to remember that. We also need to remember that our heat pump thermostat has to have that selection so that we can select B or O for reversing valve operation. Okay, so at this time, team, we're going to go ahead and just walk through wire for wire, hooking up the HMH7 with an 8E air handler. And again, please remember the AE air handler is equipped with pigtail connections. In our example, we're also going to be featuring a two-stage heat strip. So there will be a W1 and a W2 for auxiliary heat. So from our thermostat, we're going to go from B to B outside, and that's going to be for reversing valve operation in the heating mode of operation. So be sure and set that thermostat up for B for heating. W2 will be our second stage auxiliary heat, and W1 will be our first stage auxiliary heat. And that'll go all the way through to the outdoor unit. Because remember, team, we're going to have a W input from the outdoor unit anytime we're going to have auxiliary heat during defrost. So W from the outdoor unit will energize the first stage of heat strip during defrost. This is very typical. Now, one thing I need to make everyone aware of as well, based on your heat pump thermostat, we show a W1 and W2 on the heat pump thermostat, but please remember, based on the brand of thermostat that you buy, the W1 and the W signals might be called AUX, A-U-X. They might be called W1 and W2. They may be called the EM/W for emergency heat / W for auxiliary heat. So just be aware that whatever thermostat you're looking at, what you're looking for is your W1 signal will be your first stage of auxiliary heat. Your W2 will be your second stage of auxiliary heat, but on some thermostats, they may be labeled a little bit differently than W1 and W2. But just remember, it's your auxiliary heat. It might be AUX, it might be EM, it might be EMW, depending on your thermostat. But just remember, these are your auxiliary heat terminals. Any questions or comments so far? Everybody good? All right. Y terminal from the thermostat is going to go through and it's going to hook up to Y outside. Now, this is very interesting about the HMH heat pump. We only need a single Y terminal outside. We don't have a Y1 or a Y2 outside. You're going to see why here in a little bit. So the unit outside is a fully modulating system, and it modulates from 35 to 100% capacity. And it does that with just a simple Y signal going outside from the thermostat. But the way the unit works outside, what it does, now remember, team, on the indoor coil, you're going to have just a conventional expansion valve. It's nothing fancy. It's just a regular heat pump. You have an expansion valve on the indoor coil. However, the outdoor unit, it's equipped outside with an EEV, so it can monitor and it can also control the liquid refrigerant flow outside through its own EEV. Now watch this. We have a single Y terminal going outside, but the outdoor unit's going to modulate between 35 and 100% capacity. And what it does, it actually takes a look at outdoor air temperature. It looks at suction line temperature. It looks at liquid line temperature. It looks at discharge line temperature. It looks at suction pressure and so on. So it looks at 4 or 5 different sensors outside, and it's monitoring the refrigeration circuit as far as the pressures and temperatures on the suction line and so on. And then it makes intelligent decisions on what point of modulation or what point of capacity it's going to have. So really the outdoor units, the real brains of the outfit, so to speak, is the outdoor unit. So the outdoor unit's going to be modulating according to these pressure and temperature parameters that it's actually measuring on the outdoor unit. So that's how it actually works. But we get all that modulation and all that control with just a single Y input from the thermostat for compressor operation. Any questions or comments on that so far before we continue? Everybody good? All right. C terminal is 24-volt common. It goes from the thermostat to the outdoor unit and to the indoor unit. Goes all the way through. The R terminal is 24-volt hot from the thermostat to the indoor unit. Now, please remember, team, this does not go outside. Unlike our other products where we have an R terminal outside powering up the control outside, we don't need that with the HMH7. It's just strictly 24-volt hot from the thermostat to the indoor unit. And then the G terminal will go from the thermostat to the indoor unit. And again, that's going to be, typically, you're going to select on a G call, you're going to select the lowest speed tap on the EC motor. ECM motor. That would be very typical. So you're going to be setting up some speed taps on the motor. That's important that you understand that. When you're setting these things up, you're going to be setting up the speed taps on the motor, and G call is typically going to be the lowest speed tap on the ECM motor. Now, a couple things. We had mentioned that we've got that relay. We've got that relay, that 001 relay. So when we hook up the relay, we need to remember that one side of the relay coil itself, one side of the relay coil will be going to S1, which is the output from the outdoor unit to bring that relay on for airflow reduction. So this is going to be important that we understand how this airflow reduction works. The other side of the coil is going to go to 24 volt common so that we can operate the relay coil when necessary. We're also going to see that the common terminal for the switching contacts is going to go to Y. So anytime we have a Y call for compressor operation, we're going to be feeding power to the switching contacts on the relay. Now on the ECM motor, we're also going to select a high-speed tap on the motor, so that anytime we have an auxiliary heat call, we're going to drive that motor to high speed. Now this is very, very typical. Now you can still adjust this if you want to, but a good place to start is to just go on the high-speed tap. And the idea being is this: anytime we have an auxiliary heat call, we're going to drive that fan to high speed. That way we don't overheat the heat strip and so on. So that's very, very typical that we'll see that. Now watch this. On the normally closed contact of the motor, you're going to go over the normally closed contact on the relay, going over to the motor. You're going to select the airflow speed tap to give you 100% cooling airflow. Now team, this is important because you'll notice that with the relay just sitting there unenergized, anytime we get a call for compressor operation outside, right now, the way this relay is wired up, right now, if we get a call for compressor operation, what's going to happen is going to drive the fan to your 100% cooling airflow. 100% cooling airflow. Any questions or comments so far? Good? Okay. All right, so the relay right now, as it's configured with it just sitting there, and the relay is not energized right now, just sitting there, we're going to have 100% cooling airflow on the ECM motor. The normally open contact on the relay is going to go over, and we're going to select on the ECM motor, we're going to select a speed tap to give us about 60 to 65% airflow. Now remember, team, on the product, this might be medium high, it might be medium speed tap, it might be medium low. So you're going to have to measure your airflow and determine how much airflow you've got on your different speed taps. And you'll need to select the speed tap on the ECM motor that's going to give you about 60% airflow. And we're going to see here in a minute or two, when we energize that relay and we switch the relay, we're actually going to be going to a lower speed command, or more specifically, a lower airflow command. When the outdoor unit comes down to a point of modulation of about 60%, it's going to generate an S1 signal. It's going to energize that relay, and it's going to switch that motor to a lower speed tap. Because remember, what we want to do when we reduce the capacity of the outdoor unit, we also want to reduce the airflow inside to give you the best we can for humidity control as well as comfort. So that's the whole idea of this relay. The whole idea of this relay is to reduce the airflow when the outdoor unit reaches a point of capacity where it wants reduced airflow for comfort and humidity control. So let's go ahead and animate this real quick for you. So as you're taking a look at it, watch carefully. When the outdoor unit reaches about 60 to 65% capacity, bang, what it's going to do, it's going to energize an output on that S1 output. It'll energize the relay, and you'll notice it's going to switch the relay to our normally open contact now, and it's going to feed power to the ECM motor on the reduced airflow tap. So again, we want that to be about 60%. So let me go back real quick. There's 100% airflow right there. And then when we animate and we switch that relay, click, what we're going to do, we're energizing that S1 terminal, and we're going to energize the relay. We're going to switch that relay, and we're now going to command reduced airflow on the ECM motor. Does this make sense to everybody? Any questions or comments on how we're reducing airflow with that relay on the ECM motors when we hit about 60% capacity outside? Everybody good? Okay. All right, so we see that. We see how we have reduced airflow. Now, it should be noted that if I get a W1 call, either from the thermostat for auxiliary heat or when the unit goes into defrost, what's going to happen, we're going to command a higher speed tap, because remember, on the ECM motor, we selected high speed tap for auxiliary heat. So anytime I have an auxiliary heat call from the thermostat, or I get a defrost command from the outdoor unit, we get a W signal during defrost from the outdoor unit, we're going to switch and we're going to put a higher speed command on that ECM motor, and it's going to drive that up to our high speed tap. I'd also like you to notice that if you happen to have S1 energized at that point, and I go to auxiliary heat, that fan, even though it has two speed commands on it, the ECM motors are designed that if it has more than one speed command, it always takes the highest of the commands that it's receiving. So during an auxiliary heat call or a defrost call, we're going to drive that fan to a higher speed. In addition, W1 will be present one more time during an auxiliary heat call or during a defrost cycle. So that's basically how we wire this up. We're going to go ahead and talk about some other products here as we move forward into some furnaces and stuff. But before we do, is there any questions or comments on how this is working to reduce airflow on the indoor unit whenever we have that S1 output? Any questions or comments? Everybody good? Okay. All right. Well, team, the next thing we're going to talk a little bit about is dual fuel on a furnace. So it's important that we understand that the normal sequence of operation of the outdoor unit is to bring the auxiliary heat on for a short period of time anytime you have a heating call. And so what can happen if you have this unit hooked up to a furnace, which is a great product, by the way, for dual fuel, we just need to remember what's going to happen with the auxiliary heat call. Every time the outdoor unit sees a demand for heating, what it's going to do is going to output 24 volts on that W signal, and it's going to bring the furnace on for a short period of time, typically for about 1 minute. Well, that's not a really good thing with a furnace, because we don't want to sit here and short cycle the furnace. So what we're going to do is we're going to add, this is something brand new, by the way, in our program. We just added this about a week ago. So what we're going to do to prevent that short cycling of the furnace, if you're hooked up with a dual fuel operation, you want to make sure that if you're on a furnace, we don't want to short cycle that furnace. So we're going to choose a construction dry out thermostat of 65 degrees. Now here's an S1 part number. That S1-SC065 is an example of this type of little thermostat. It's just a little thermostat module that you're going to clamp on to the suction line on the indoor coil. And we want to make sure that you select one that's the heating type of thermostat, not the cool type. And so you can confirm the construction thermostat closes on a drop of temperature and opens on a rise of temperature by doing the following. You can take your ohm meter and hook it up to the wire leads, and then cool that thermostat down below 65 degrees. Just put it in the refrigerator, or take just a glass of ice. You don't have to have water in it. Just stick it in a glass of ice, just some ice cubes, and cool it down, and click. The switch should close electrically. You can just look at it with your ohm meter. Then take that little construction thermostat and hold it in your hand for a couple of minutes, and click. You'll see that it'll open above 65 degrees. So the point is, if you're unsure what the thermostat activity is, go ahead and double check that and confirm it with your ohm meter and a glass of ice and your warm hand. You can operate that switch. The next thing you're going to do, you're going to wire tie or tape you're going to mount this construction thermostat on the large vapor line of the indoor coil, and you're going to insulate it. Now, guys, this is important because if you don't utilize this, what's going to happen, you can have some short cycling of the furnace. Now, it probably wouldn't hurt it in the short term, but in the long term, if you're only running the furnace for like 1 minute every time you have a call for heat on this heat pump, what's going to happen, it's going to potentially rot the heat exchanger out, especially if you're on propane. So we don't recommend that you short cycle the furnaces, and this little construction thermostat will prevent that. The next thing you're going to do, you're going to wire that thermostat into the W wire from the outdoor unit to interrupt the auxiliary heat input from the outdoor unit to the indoor control board. So as we take a look at it, this is what that little construction thermostat looks like. So you guys have seen these before, the sheet rockers and all, they'll use these to run the heating equipment, to dry the house out, when they're doing their sheet rock. So again, this is a heating thermostat. It opens on rise of temperature, and you're going to select one that's 65 degrees. And again, the source one part number is an S1 SC065 is typical. And remember, the color red is for the heating thermostat, is for the heating stat. And again, this is something we've just added within about the last week. If you're doing dual fuel, we're going to recommend that you use this. And again, mount it on the suction line of the indoor coil, and then you're going to wire it into the circuit. Here's an example right here. So basically all we're doing with that little construction thermostat, if you look at my cursor closely, what we're doing is we're just breaking the W wire from the outdoor unit to the indoor unit. And so what this is going to do, let's walk through what this is going to do. Typically what this is going to do is it's going to, when the outdoor unit calls for heating operation and the switch is open electrically, it's going to keep the furnace from coming on during, as long as that suction line is about 65 degrees. Now, during defrost, when we go to defrost, remember team, when we go to defrost, the heat pump is going to go into the cooling mode of operation during defrost to defrost the outdoor coil. When it goes into defrost, that suction line is going to get cold. And what's going to happen, this switch right here will close on a drop of temperature, and it'll bring the auxiliary heat on after, maybe a minute or so once you're into defrost. Once you come out of defrost and you're back in the heating mode, that, remember, on a heat pump, the indoor coil is the condenser in the heating mode. So when it goes back into the heating mode, that suction line is going to get real hot pretty quickly because it's the hot gas line in the heating mode, right? And so what'll happen, this switch will open pretty quickly when it go back into the heating mode. So the idea is, again, this little switch right here, that little construction thermostat, we're going to be breaking the W wire from outdoor unit to the indoor unit on a gas furnace. And when we do that, it'll prevent that short cycling of the furnace. And by the way, we do have a service tip letter that was launched about 3 or 4 days ago that outlines this. And if you don't have that, be sure and get up with me later on, or let's make sure that your regional account manager gets that to you. But if you're doing any kind of dual fuel operation with the HMH7 heat pump, we're going to recommend that you put this little construction thermostat. You can see my cursor. Electrically, you're going to break that W signal from the outdoor unit to the furnace inside for auxiliary heat. Any questions or comments on that before we jump into some furnaces and we start looking at hooking up some furnaces for dual fuel application? Any questions or comments? Everybody all right? Okay, well, fantastic. So at this time, let's go ahead and jump into some furnaces then. We're going to be looking at the TME and the TMY standard ECM furnace. And just like we did before, we're going to have some simplified block wiring diagrams to look at. And we're going to take it wire for wire. And we're going to be featuring that single pole double throw relay again in the indoor unit, that what we call the HMH. The 001 kit is recommended for all the convenience and supplied parts. Now, please remember also, team, that the heat pump thermostat has to have that BO selection, still has to have that BO selection for reversing valve operation, and make absolutely certain that you select a heat pump thermostat with dual fuel function. Let me say that again. You have to have a heat pump thermostat with dual fuel function anytime you use it with a furnace product. So let's go ahead and pull that block wiring diagram. And as you can see, there we have that construction thermostat in the circuit from the W wire outside coming into the W signal inside on the furnace. We do have that construction thermostat in there, which is recommended for dual fuel application. In addition, you'll also notice that our thermostat is dual fuel capable. But just like we had before, team, we'll pick up the pace a little bit because it's essentially the same way. We're going to wire it just like we did before with an AE air handler, but it's a furnace this time. And so W1 from the thermostat, because the TME is a single stage furnace, we only have one heating terminal. And so W1 will go to W on the furnace and then outside through that thermostat, through that construction thermostat to W outside. Y stays the same all the way through. Common is all the way through again, just like we saw before. It's pretty straightforward. 24-volt hot goes to the indoor unit, but it does not go outside. Remember, that's important. It does not go outside. And G terminal is 24-volt fan call. Now, on the relay itself, we're going to notice it's pretty standard like we did before. One side of the coil goes to S1. The other side of the coil goes to the common terminal so we can complete the coil circuit on the relay. The common terminal on the switching contactor will go to Y terminal, just like we had before. So anytime we have a compressor call on Y, we'll feed power to the relay switching contacts. Now the normally closed contact on the relay will go to Y/Y2. That's our high-speed airflow input on the furnace control that commands high-speed airflow. And again, we're going to set that up for 100% airflow. We want to make sure we adjust our airflow for 100% airflow on a Y/Y2 call. And then the normally open contact will go to Y1, our first stage of cooling airflow. So this is our block diagram for the TME single stage heating, two-stage cool furnace. An example would be like a TM8E or a TM9E furnace. This is how you're going to wire the thing. Any questions or comments on how to wire this up or the block wiring diagram? Good. Okay. All right, so the TMY furnace, the TMY is a two-stage heat. Now you're going to notice something. The TMY furnace, the low voltage wiring and relays and all, it wires exactly like the TME. The only difference is the TMY is a two-stage heating furnace and requires a W2 and a W/W1 terminal. So let's go ahead and wire that in. We'll see W2 goes to W2. Very, very straightforward. And then the W1 is going to go to the W/W1 terminal. So you can see real briefly right now that other than a little bit of extra wiring, we have a two-stage furnace now, so we have to accommodate that W/W1. That's how it's identified as first stage auxiliary heat, and then W2 on the two-stage furnace. So other than that, it wires exactly like the previous example. Let's go ahead and animate this so you can see how this is going to work. Again, what we're going to do is that anytime we have an S1 output from the outdoor unit, it's going to energize that relay. Let me animate that one more time for you. So anytime we have an S1 output from the outdoor unit, bang, we're going to switch that relay and we're going to command low airflow, or in this case, Y1 airflow. Now, team, please remember when you set up these furnaces, you want to make sure that you set your airflow up for 400 CFM per ton. So if I've got a 2-ton unit sitting outside, I'm going to set it up for 800 CFM. And then your reduced airflow, your Y1 input, your reduced airflow needs to be about 60% of your high-speed airflow on that airflow reduction. So it's pretty straightforward, but that relay, the reason we have that relay is to allow the outdoor unit to have reduced airflow on the indoor coil for humidity control and comfort. By the way, please write this down and remember it. Our HMH7 product, it comes in whole tonnages, 2, 3, 4, and 5 ton units. There are no half tonnages. It's just strictly whole tonnages, 2, 3, 4, and 5 ton on the outdoor unit. Any questions or comments on hooking it up with a furnace? And we've got that little construction thermostat and all that. Any questions before we jump into some variable speed stuff?
Could you hit over that construction thermostat a little bit? We're still a little gray on that.
Okay, so what it is, it's basically it's just a little cartridge thermostat, and they're very inexpensive. I mean, they're typically under $10. They're just a little construction thermostat that you know, sheet rockers and stuff will use and whatnot. They'll just to hook up a furnace to dry the house out. And you know, the part number we showed you, that S1-0C65, is just an example of one. If you go online and Google it, ICM, the company ICM that makes controls, they make them. I think Honeywell maybe makes them too. There's various companies that make them. But that little construction thermostat, basically all it is, it's a little temporary heating thermostat that you'd put into a home or a space. So instead of having, you'll see it sometimes when the sheet rockers are in there doing work in the house, and it's in the wintertime, they want to heat the house up to dry the sheet rock out. So what they'll do is, where the thermostat's going to go on the wall, they'll just grab the R and the W terminal or wires, and they'll just wire this little thermostat in, and they'll just let it hang there on the wall to heat the home up. And so what it does is just a little thermostat, just a little cartridge thermostat that's going to close at about 65 degrees and open. It's going to operate at about 65 degrees. Now, once the temperature comes down like 63, click, it'll close. When it gets up to about 66, click, it'll open. But with the range of about 65 degrees operating. So that's all that is just a little construction thermostat, a little cartridge thermostat that you can heat a space to, you know, a single point temperature construction thermostat. That's all that is. Well, we're going to take one of those, and we're going to break that W wire from the outdoor unit to the indoor unit. And then we're going to wire tie and tape that little cartridge thermostat on the suction line of the indoor coil and insulate it. And then wire it in with a couple low voltage wires, you know, into the furnace here. And we're going to break that W signal from the outdoor unit to the indoor unit. That's the sole purpose of that is to prevent the furnace from short cycling every time we get a heating call, because the heat pump outside is designed to bring on the auxiliary heat for about a minute to kind of warm the air up a little bit. The whole idea being that it warms the air up before the heat pump comes up to full speed. It's a comfort thing. It's strictly a comfort thing. And so but when you put this on a furnace, what's going to happen, the heat pump, it's going to bring the furnace on, but it's only going to stay on for about a minute before it shuts it right back off. Well, eventually, if you're sitting here running that furnace for only 1 minute, you know, let's say you have a mild winter and you're running that furnace for just 1 minute, and the heat pump is taking care of it all the rest of the time. Well, if you're sitting here short cycling that furnace over a course of time, and it's not heating up like it's supposed to, and it's not coming up to full speed like it's supposed to, it can start corroding the heat exchanger, especially with propane. Because the big thing about propane, you want to make sure that furnace comes up to speed and gets good and hot in between cycles. That way you don't corrode the heat exchanger. So that's all this is about. Number one, it's a comfort thing. But number two is to give us system reliability so we don't short cycle the furnace. That's what that's all about. Good question. Any other good questions or comments? Everybody good? Okay. All right, so team, at this time, we're going to take a look at some variable speed air handler and a variable speed furnace. And just like we did before, we're going to have a low voltage wiring, a block diagram. We're going to look at those block diagrams. Now, it should be noted, some of the terminals that we're not going to be using for the HMH7 outdoor unit are not covered. For an example, we're not going to talk about the humidifier terminal. or the dehumidifier terminal, or the electronic air cleaner terminals, because that doesn't have any function. So this is a simplified block wiring diagram. So there's some terminals on the variable speed unit that we're not going to talk about, only because it has nothing to do with the outdoor function, and just to keep the block diagrams nice and simple to look at. Now, please remember, team, on the variable speed products, it doesn't matter if it's a variable speed air handler or if it's a variable speed furnace, you're going to have to use that 002 kit, that 002 relay kit, because it has 2 relays on it. And those relays, we're going to be using both of them. So make sure that you have the 002 kit for the variable speed product. And again, we recommend these kits for convenience and all the supplied parts in there. Please also remember that on the heat pump thermostat, you have to have that BO selection for reversing valve operation. And if it's on a variable speed furnace, don't forget, it also has to have dual fuel capability if you put it on a furnace. So let's go ahead and start out. We see now that we have 2 relays. Let's start out with the variable speed air handler. And we have a 2-stage heat strip in this air handler. Now, please remember the air handlers do have pigtail connections, but we're just showing them on the block diagram so it's easy to look at. So B terminal, just like before, goes to B outside. That's going to be our reversing valve for heating in the heating mode of operation. W2 is our 2nd stage auxiliary heat. W1 is our 1st stage auxiliary heat. And by the way, you notice we don't have that construction thermostat on the air handler, because what we're doing is we're going to, anytime the air handler, or more specifically, anytime the outdoor unit calls for heating operation, it's going to bring the heat strips on for about a minute to kind of preheat the air. Because if you think about it, it's a comfort thing, because if you think about it, you know, a lot of times the complaint you'll have from a homeowner, especially if they're new to heat pumps, if they're not used to a heat pump, is, gee whiz, this thing kind of blows cold air every time it starts. Is it supposed to do that? Well, so what the HMH7 engineers did when they designed this, they said, okay, well, let's bring the heat strips on for about a minute to kind of preheat the air every time we go into the heating mode of operation. So that's what that's all about. It's actually designed to do that. And we learned earlier that on a furnace, we don't want to short cycle the furnace. But if you have a heat strip in an air handler, that function of kind of preheating the air a little bit makes it more comfortable on that initial call for heating. So that's what that's all about. That's why it brings that on. It brings the heat strips on just to kind of temper the air or warm the air up every time it goes into the heating mode on an air handler. But we learned earlier that on a furnace, we don't want to short cycle the furnace. That's why we've got that little construction thermostat in that W circuit on the furnace, so we don't short cycle the furnace. Y signal goes outside, just like we had before. You know, for our compressor call, C is our 24-volt common. That goes all the way through. R is 24-volt hot, and G is our fan call. Now, again, team, you'll notice that we've got 2 relays, and we're going to show you how that works here in just a second or two. So as we take a look at those relays, one side of both relay coils are going to go to 24-volt common. On the other side of the relay, the B terminal, or the other side of the relay on the S1 relay, that goes up to the S1 terminal. This is going to be our airflow reduction relay like we had before on the other products. We're going to have Y terminal feeding the common switching point for the switching contacts on the relay, 24 volts to common on the contact. The normally closed contact on the S1 relay will go to Y/Y2. The normally open contact on the S1 relay will go to Y1. Again, this is our airflow reduction. The B terminal, this is important, the B terminal on the RV relay is going to go up and hook up to the B wire going outside for reversing valve operation. Another way of thinking about that RV relay is we're going to energize that relay anytime we go into the heating mode of operation. Anytime we go into the heating mode of operation, we're going to energize the RV relay. The common terminal for the switching contacts on the RV relay are going to go up to Y as well. So anytime we have a call for compressor operation, both relays will be energized and ready to go to work. Now watch this, the normally closed contact on the RV relay is going to go to the O terminal. So on the variable speed product, here's why we have that RV relay. On the variable speed product, we have to tell the indoor unit on a heat pump, we have to tell the indoor unit when it's in the cooling mode of operation. And so this drives some advanced functions like some of your cooling on delay and some of your fan relay operations. In addition, it also drives some dehumidification functions on the variable speed product. So the bottom line is on the variable speed product in the cooling mode of operation, we need 24 volts on that O terminal on the air handler, on the variable speed air handler or the variable speed furnace to tell it it's in the cooling mode of operation for some advanced cooling dehumidification functions, right? And so we're going to utilize that relay, that RV relay, to feed 24 volts to the O terminal on the variable speed products for some advanced functions. However, when we go into the heating mode of operation, we've got to break that O terminal in the heating mode of operation. So you'll see the way it's wired right now that when we energize the B terminal for heating on the heat pump, what's going to happen, it'll energize that RV relay and it's going to break that O terminal, and that's exactly correct. In the heating mode of operation, we want to tell the air handler that we no longer have the O signal in the heating mode. And so that's exactly what that relay is for. The only reason that relay is there is to switch the O terminal off in the heating mode. But in the cooling mode, we want to have power going to the O terminal in the cooling mode on the variable speed indoor product for some advanced dehumidification and some advanced fan functions. So any questions or comments on what that second relay is all about? Any questions or comments? Everybody good? Okay. So as we take a look at that, basically we just have that second relay in that circuit for everything I've just described. Now the TMV furnace, now please note something, the TMV furnace, the wiring is the same as the AVC air handler, except the heating terminals are slightly different. They're labeled a little bit differently. And the furnace has that heating thermostat, that little construction, that little heating thermostat wired into the W circuit from the outdoor unit. So the only difference between the wiring schematics is the fact that you just have that little switch on the furnace product, on the W/W1, and then please remember also you have to be sure and have a dual fuel thermostat. So let's go ahead and watch this. Now remember, the TMV furnace requires that dual fuel thermostat like I just said. And as we start getting into some of the switching of the relay, and you can look at the animations on how they work. So let's go ahead and look at the animation on the relay on the right-hand side. Bang. Just like we had before, let me do it again. Just like we had before, when I go to the S1 output on the outdoor unit, we switch that relay and we command low airflow or Y1 airflow on our variable speed units. On the RV relay, watch the RV relay. On the RV relay, when we go into the heating mode of operation, one more time, when we energize B terminal in the heating mode of operation, you'll notice, bang, we're going to energize that RV relay and we're going to break that O signal. And we talked about why we did that. So the only thing that RV relay is doing is just breaking the O signal in the heating mode of operation, because the O signal drives some advanced functions in the cooling mode. When the air handler knows the variable speed product is in the cooling mode, we've got the O terminal, it's in the cooling mode. But when we go into the heating mode of operation on our heat pump, we energize B terminal, bang, we break that O signal, and we disable that O signal and those cooling advanced functions. Any questions or comments on the relay logic, how we're reducing airflow, and how we're hooking these things up to a variable speed product? Any questions or comments? Everybody in good shape? Okay. All right. Well, team, some things we always want to remember on the HMH7 is we want to confirm proper airflow, because remember, the HMH7 is a modulating capacity unit, and nominal airflow is going to be critical. So be sure and size your ductwork to provide 400 CFM per ton of total capacity. So again, if I've got a 2-ton unit outside, I need 800 CFM. If I've got a 3-ton unit outside, I need 1200 CFM, and so on. So please consider that. Make sure your ductwork's in good shape and you're providing the airflow that's necessary for the tonnage of the outdoor unit. Well, these are some velocity tables. These are velocity tables right out of Manual D, and we're going to recommend that you always follow Manual D, ACA Manual D. That's your airflow and duct design criteria. And this velocity table is just a reminder of everyone that when we're building a duct system, we want to make sure our velocities are right in line as well. Not only the total CFM, but also the speed or the velocity of the air. And you can see there's, Manual D, and we're not going to go over every little point in here, but we want to bring out some reminders for everybody that velocity is an important component of designing a duct system. For instance, the recommended velocity on the main trunk is 700 feet a minute velocity, not to exceed 900. Your branch runs, you want 600 is recommended. Registers, grills, and diffusers, about 500 feet a minute is recommended. With a maximum of 700, you get the idea. So this velocity table is important when we design a duct system. One of the big things that I like to remind everybody too is that if you've got a filter grill, in other words, if you've got a return grill with a filter in it, you want to make sure you do not exceed 300 feet a minute across that filter. Another way of putting that is that if you've got real high velocity going across that filter, the filter is not going to work as well if you have too high a velocity across that filter. In addition, it's going to be noisy and it's going to whistle and all that kind of stuff. So please remember that we want to make sure our filter grills, if we have a return grill with a filter, we want to make sure that they're plenty large enough to provide, good filtration and not to exceed about 300 feet a minute velocity across that face of that filter. And by the way, team, at some point, if we need to do a airflow and duct design class with you guys, we'll be glad to do that for you sometime. Get up with Jill, and we'll be glad to schedule some airflow training with you as well. So with that, let me go ahead and open the floor up for a minute or two. I'm going to go ahead and shut my PowerPoint off and stop sharing my screen. I'll get my camera back on real quick. And let's go ahead and open the floor up for a minute or two for any final questions and comments.
All right, so one thing that we've got, and this is kind of a big thing for me on HMH7, is the line set coming out the side goes straight up. Is there a way to change that? Because aesthetically speaking, when you're bringing a line set out of a basement, it looks terrible, to be point blank.
That's a good comment. What we've done is we've actually requested Hisense to reposition those, and they're looking at doing that for us. One little news flash is on the straight cooling unit that we have. The service hose fittings are 1/4 inch instead of 5/16. So we've asked that they do that on the heating on the HMH7 as well. So, the next batch of HMH7s should have some enhancements on there, but we've asked them to do that, and they're looking at doing that.
So, because that was the limitation too. If you lost your tiny little fitting, there's nothing you can do on these HMH7s.
Yeah.
One other thing, just kind of as a note, if y'all are putting in recommendations for the future, the last one I installed, all the screws were 7mm screws. They weren't your typical 1/4 or 5/16. It's not a big deal, but it was extremely aggravating. I'll tell you that.
Okay, I wasn't aware of that. Thanks for that field tip. I didn't realize they were metric, but I'll ask about that. So basically, 7mm, you had to have a 7mm nut driver instead of a quarter inch or 5/16. Okay.
Which I know none of our technicians anyway carried 7mm sockets on us because it's not typical. So every single screw had to be taken out with a Phillips screwdriver. And then I replaced every screw with a quarter inch for serviceability purposes.
Okay.
But that's kind of one other thing if they're getting more popular over here.
Okay.
And
Yeah, I'll definitely bring that up on one of our product meetings next opportunity I have. Thank you for that intel. Well, good. Well, good questions, good comments. I'm going to go ahead and stop the recording at this time, but that doesn't mean we can't continue to talk some. Now, please remember, we'll have this recording out on the YouTube training channel, and it'll be called HMH7 Overview, and today's date 11/02/2022.